Hello, my name is Hari Sankar. I'm responsible for product management and strategy for Oracle's enterprise performance management business. In today's session, I'll be discussing how we are leveraging emerging technologies such as machine learning and predictive analytics to help modernize the finance function. So, as all of us know, the finance function has been going through a lot of changes, especially in the last few years. So, what do we see when we look uh, look out several years, say over the next 10 years, what sort of changes do we see for the finance function? So here's a point of view from the strategy consultants at McKinsey and Company. They see the following as some of the key imperatives for the finance function over the next decade or so. The first one is the finance function needs to be able to deliver much better insights in real time. The second element they see is that finance function needs to find ways to help minimize human error and biases. And the third imperative, in their opinion, is finance function needs to be able to drive speed in business processes and especially in decision making. So at Oracle, we agree with this point of view very much. In fact, the way we see the future of finance is very much aligned with these ideas. So we believe three core ideas will define the future of finance. The first one is that the finance function of the future is going to be highly connected. It's not the traditional bookkeeping role, it's a strategic advisory role. What that means is finance needs to be actively collaborating with operating functions such as sales, marketing, human resources, manufacturing, supply chain, and so on, and helping to provide input and influence in actively shaping every strategic decision that is being made in an organization. So it's a highly connected function. Second is that finance needs to find ways to incorporate what we call data-driven intelligence in every aspect of decision making. The idea is that data-driven intelligence needs to be blended with human judgment to drive the right decisions. And when we talk about data, we take a very broad view of data here. It's not just financial data. It's the combination of financial data and operational data from other functions such as sales, marketing, human resources, and so on. It's also not just internal data. It's a combination of internal and external data. So it's the blending of data-driven intelligence with human judgment that'll drive the right decisions going forward. The third element of what's going to be different about the finance function of the future is that finance needs to find ways to automate low value activities. So there is a lot of manual labor in a lot of areas of finance, whether you look at financial planning and analysis, or whether you look at financial consolidation and close activities or reporting activities. There is a lot of manual labor today. So going forward, finance needs to find more and more ways to automate this manual work and free up people in finance, whether they're executives or regular employees in finance, free up their time to focus on higher value added activities. So connected, intelligent, and automated. Those are three elements of how the finance function of the future is going to be different. So keep those in mind. We'll keep coming back to these three ideas throughout this presentation. So let's take a look at where technologies such as artificial intelligence and machine learning find use in finance. So here's a point of view based on a survey conducted by the APQC organization, American Productivity and Quality Center. I'm sure many of you are familiar with this organization. So they ran a survey of hundreds of organizations, as you can see here. And these, what you see on the slide, came out as the top use cases for the use of AI and automation in finance. I'm not going to go through this list of 10, but let me pick out about half of these areas which are closely related to enterprise performance management. So the second from the top is close and consolidations. Further down is financial forecasting. The one after that is payment matching. Further down, you see the last two, financial planning and master data management. So you can easily see that at least 5 out of these 10 use cases for AI and automation within finance are closely related to enterprise performance management, which is why we are investing heavily in leveraging AI, machine learning, and automation technologies in the context of enterprise performance management. Let's look at another piece of data, again from APQC from last year. This is a survey of about 1,000 organizations in terms of where organizations are adopting technologies such as artificial intelligence and machine learning in the finance context. So the top areas came out as purchase to pay, record to report, order to cash, and most importantly, in the context of this presentation, financial planning and analysis, FP&A. So if you look at the data in the last row here, over 50% are piloting the use of AI in the context of financial planning and analysis, or have already in some fashion implemented AI and machine learning technologies for FP&A use cases. So over half of the 1,000 organizations surveyed last year see AI and machine learning technologies as very, very suitable for FP&A processes. So keep this in mind, and we completely agree with this because this is what we see as trends in the market, trends in terms of what our customers are doing, and which is why we are making significant investments. We've been doing this over the last several years to leverage machine learning technologies, predictive analytics technologies, and automation technologies to help improve specific processes within enterprise performance management, especially in the context of financial planning and analysis. So let's drill into the details of what we are doing, what we have delivered, what the roadmap looks like for the adoption of machine learning technologies in enterprise performance management. So the overall initiative that drives our vision, our strategy, and our investments in this area being the use of predictive analytics, AI, machine learning, and automation technologies, specifically in support of our vision for the future of finance. The vision, as you remember, consists of three key elements. Finance is going to be highly connected, leveraging data-driven intelligence, and looking for automation opportunities in the context of finance processes, right? So intelligent performance management, or IPM, is the umbrella initiative that drives our vision, our strategy, and our investments in this area. So IPM, you will hear this acronym IPM a lot. IPM is the umbrella initiative under which we are making a lot of these investments to deliver functionality today and into the future. So let's take a look at IPM, what it's about, what we've delivered, and what the roadmap looks like. So here is a high-level functional architecture of intelligent performance management. So this is a sort of a complex diagram on the face of it. So let me sort of tease apart some of the details on this picture. So you see the red line in the middle. Above the red line are functional capabilities that we are delivering to business users in finance. Below the red line are platform capabilities or technology infrastructure that helps deliver the functional capabilities that business users see and use. So below the red line is technology, above the red line is business user functionality. So let's start from above the red line. Take a look at what do we mean by business user accessible functionality. These are things like predictions. So we want to use machine learning models to look at data and make predictions. So forecasting is inherently a hard thing. So can we help improve human forecasts by providing machine predictions, computer-generated predictions, to help improve the accuracy of forecasts? So that's the idea of predictions. Simulations is, can I run simulations as a way to help reduce risk in my planning processes, in my forecasting processes, and so on? Correlations. When we look at data, some of the data may be highly correlated. For example, my sales may be highly correlated to economic metrics, overall how the economy is doing, or overall how my customers are doing in their businesses, and so on. So how can we use learning models, AI and ML technologies, to find these correlations and make use of these correlations to help improve our forecasts? The fourth one is an important one. We've delivered some very interesting capabilities in this area recently. It's insights. How can I use machine learning models, pattern recognition algorithms to find insights from data without my users having to do a lot of legwork to get the data, clean the data, analyze the data, and find the insights? Instead, can we use pattern recognition algorithms and machine learning models to find these insights and deliver these insights to my users so that they can take action on these insights and focus on taking the action as opposed to finding the insights? Right? So those are some examples of what we mean by end user functionality available in this area. And below the red line, you have platform technologies and capabilities that help deliver these functionalities. There are things like auto predict. Auto predict is a piece of functionality that we've already delivered. This is based on statistical regression models. We'll talk more about this later. The second element is AutoML engine. So this is a machine learning engine that we are embedding within the EPM platform to help drive machine learning based predictions. And these machine learning models can be defined within EPM using the AutoML engine, or they can be externally defined in platforms such as Oracle Cloud Infrastructure, OCI, specifically the Oracle Data Science Cloud, or they can be defined elsewhere using cloud infrastructure from Amazon or Google or Microsoft. So the idea here is data science teams within your organizations may have built these models already. So rather than reinventing the wheel by redefining these models within Oracle's EPM platform, what we do is allow you to import these models using standards such as the PMML markup language. You can import these models into EPM and leverage these models in the context of EPM processes, EPM decisions, and so on. So that's what we mean by ML model import. And at the bottom layer, you see the orchestration and insight engine that helps deliver the insights that I talked about earlier. So the bottom layer is technology, both Oracle technologies in the context of EPM, as well as broader technologies in the context of Oracle Cloud Infrastructure or cloud infrastructure from other vendors, right? So this is a very open architecture, as you can see. This is a very open framework. The idea, ultimately, the value comes from the upper half of this picture. Business user functionality that helps improve decision-making, that helps deliver insights to business users. So that's the idea behind intelligent performance management. I know we've packed a lot into this one slide, but hopefully this makes sense. So IPM is a very important initiative at Oracle. This is not about a single piece of functionality. This is a long-running initiative through which we've been delivering functional capabilities, through which we have an active roadmap for delivering functional capabilities. So in today's session, we're going to look at some of these elements in more detail. So let's start with the whole philosophy behind this approach within IPM. The idea here is, look, we're not saying human forecasting is bad, machine forecasting is good. Both approaches have their place. Because if you look at machine learning based predictions, machine learning models can be fast, they can be very accurate, they're not subject to biases unlike human beings, but they do not have the domain knowledge or the business context that human beings have. So sometimes they can come up with recommendations or predictions that do not make any sense because they do not have the business context or the domain knowledge, right? So they have many positive attributes, but they also have some negative attributes. On the other hand, human forecasters in finance, they may be slower, they may be less accurate, they may be subject to their own biases, but they can be very insightful because they understand the business very well. Their experience-based insights can be brilliant. So the idea that IPM comes to the table with is really how can we combine the best elements of machine learning models and human judgment-based decisions to come up with forecasts that are really combining the best of both worlds, right? So that's the idea. Machine predictions will complement human forecasting, and that's the core idea in IPM. Another tenet within IPM is that, we know people in finance are skeptical. Because if there is a black box machine learning model that makes a prediction, people in finance are not going to just accept that prediction and run with it. They will want to know why the model is predicting or recommending what it's recommending, right? So we'll talk about this idea of transparency or explainability later, but keep that idea in mind as well. Okay. So now let's talk about a couple of key elements of functionality that we've already delivered through IPM. Predictive planning. This capability has been available in Oracle Cloud EPM for a number of years now. Hopefully, many of you are already using it. And in the last few years, we've already also introduced a capability called Auto Predict, where as new data comes into the planning system, comes into the EPM system, we automatically use statistical models to generate predictions and load those predictions. So, we all know about doing variance analysis, which typically compares actuals to the forecast, right? An emerging new best practice, which many of you are actually already doing, I'm sure, is a three-way comparison where you're comparing actuals against not only human forecast, but also machine-generated predictions. So actual versus forecast versus prediction, that three-way comparison has become the new best practice, right? So when you start doing that, you're shifting analysis to be more forward-looking as opposed to backward-looking, because variance analysis is inherently backward-looking. You're just looking at, okay, I made a forecast. How did that turn out is all you're doing for the most part. In this new model, you're looking ahead to see, okay, if the machine learning model is doing a much better job of predicting the future compared to my human forecast, should I make adjustments to my human forecast using the output of the machine learning model? That's the core idea here. So predictive planning and auto predict are capabilities that are already available in Oracle EPM. Hopefully you're using them. If not, take a look at these. There's a lot of value to be gained by deploying these best practices. IPM Insights, like I said before, is a new capability that we introduced in 2021. This is a very exciting piece of functionality. In fact, many of our customers have already deployed IPM Insights in the past several months, and many more are piloting this capability to see how they can make use of it in their business context. So let me talk about the core idea behind IPM Insights. The core idea is that today, the process of finding insights from data is very complex, very cumbersome, involves a lot of manual work. So let's take a look at what's involved in finding insights from data. Oftentimes, people in finance, employees and analysts and executives in finance have to consolidate and pull together data from multiple systems, ERP systems, internal systems, external systems, and so on. Then you have to clean the data, you have to consolidate the data, you have to analyze the data, run some reports, pour through these reports to find patterns, data patterns, or observations that look interesting, right? So loading the data, cleaning the data, prepping the data, analyzing the data, running reports, finding patterns, finding interesting observations. So you've spent a lot of time, oftentimes days worth of work, before you've come to identify insights that look interesting. And then you have to review these insights with business stakeholders and then finally take action. This process is so tedious, so time consuming, so manual that oftentimes when you find an insight, the time for taking action based on that insight is actually passed. So what we are trying to do with IPM Insights is flip this equation where you have to spend a lot less time finding the insight and you have a lot more time to take action based on the insight. So the core idea here is we have a machine learning based, data science based pattern recognition engine that's always running in the background and looking for insights and finding insights. And it always presents the insights to you in near real time. So we find the insights for you, we present the insights to you. And again, we do intelligent things like, okay, not every insight is equally interesting. So you can set threshold, you can define what materiality means. So we do a lot of the, heavy lifting in terms of finding the insights, filtering the insights, and presenting to you in prioritized order the interesting insights at any given point in time. So every day you come in, you take a look at 6 or 8 or 10 insights that are interesting to you. And then you focus on collaborating with business stakeholders and taking action based on these insights. So algorithms do the heavy lifting. We free up your time to fix issues and take action. So this really opens the potential for faster cycle times. This enables and empowers the finance function to be a strategic partner with the lines of business, whether it's sales or marketing or human resources, right? So that's the idea. So it's a very powerful idea. We find the insights for you. You focus on action. It's a very powerful idea. And that is why it's capturing the imagination of many of our customers. So let's take a look at this in a little more detail. The reason we are using machine learning models to find these insights is that data analysis is inherently difficult, right? Because we say data analysis, it's actually a complex process, because when you see a pattern in the data, you need to tease apart several elements in this data pattern. So the diagram on the left shows you a quick example of this. When you see a pattern in data, there is a trend that's going on. There's seasonality that's going on here. Seasonality means, during holiday season, my sales peak. So we need to capture that, right? And then there is this residual information, which is what we need to pour into to understand if there is anything interesting going on here. So we need to tease apart trend information, seasonality information, and other significant information. For example, if you made a price change, that may result in a downward movement or an upward movement in your volume of sales. So all those things need to be teased apart before you see what is interesting in the data that you're looking at. So human beings are inherently not very good at doing this. It takes a lot of effort for human beings to find these patterns and trends and seasonality and isolate them and find the interesting nuggets. So essentially what IPM is all about is really, finding insights is really like finding a needle in a haystack. Machines are much better at doing that. So we are employing machine learning models to do that. That's the core idea here. So what do we mean by insights? There are many different types of insights that are available here. The first is, forecast variance and bias. So really, we look for variances. Variance analysis is easy. Machines can do it very well. Bias is an interesting concept because, let's say you're assembling sales forecast based on input from different regions of your organization. The North America region may be inherently optimistic, and they may be giving biases that they may be giving forecasts that have an optimistic bias. On the other hand, the European organization may be a little more conservative, and they may be giving forecast input that's a little pessimistic in nature. So if you understand this pattern, then you can correct these biases and make your forecast more accurate. That's the whole idea. Prediction insight is really, as I said before, if machine learning models are doing a better job of aligning with actuals, then you may want to correct human forecasts using the machine learning model as an input. Anomalies are outliers. Machine learning models are very good at detecting these outliers, so you can remove these and improve the forecast accuracy. So these are some examples of the types of insights that we already deliver today, and we're working to deliver a growing set of these kinds of insights over time. So what is the benefit of IPM Insights? At the end of the day, it's really about helping you reduce the amount of manual labor or grunt work, focus on value-added work, eventually leading to better decisions. So the chart you see here is really about how the finance function has been steadily improving the amount of time spent on value-added activities. 9% improvement in FP&A, over 30% improvement in certain other areas such as tax and treasury and so on. So Insights is yet another tool in the toolkit for the finance function to improve their ability to focus further on value-added work. So less grunt work, better decisions. So as I said, some prediction options are already available in Cloud EPM. We talked about predictive planning and auto predict. These are based on statistical algorithms, which are called univariate statistical algorithms. If you wanted to do multivariate analysis, things like regression or classification using multiple variables, for instance, sales may be affected by price and promotions and economic activity and industry level activity and so on. If you wanted to do this multivariate analysis, today we support the import of machine learning models from other systems, Oracle systems or non-Oracle systems. Going forward, what we're going to be doing is embedding an AutoML engine within Oracle Cloud EPM to allow you to define and manage machine learning models directly in Oracle Cloud EPM. So you can define machine learning models, you can train these models using sample data, you can deploy these models and manage these models within Oracle Cloud EPM. In defining and making use of these models, we have two approaches. The first approach is what I show on the bottom, called recipe-based machine learning, which means at Oracle, we identify specific use cases, say cash forecasting or cash management, build a machine learning model for you. We let you configure it using your data, but we do all the heavy lifting in terms of data preparation, feature engineering, to find the elements of the model that are interesting, do predefined data integration, and build a machine learning model that can be configured and tuned using your data, right? So that's what we call recipe-based machine learning. The other idea is open machine learning, which is where you come up with a different problem that's not broadly applicable to a lot of customers, that's very unique to your business. So you train the model using your data, and you create this model and use that machine learning model for predictions. So recipe-based model, machine learning, and OpenML, both are available. In both cases, there are a couple of elements that I want to highlight. The first one is the idea of explainability. So this is all about providing transparency in machine learning. So we not only give you a prediction, we tell you what's behind that prediction, what factors or what variables are most influential in coming up with that prediction. And these variables can be global, applicable across many different predictions, or local, specific to this given prediction that we're making. For example, the forecast for November 2022 that we're making right now has been most heavily influenced by these factors or these variables. So things like that, global, local, and business explainability. Business explainability relates to specific events that may be influencing the prediction. The key thing is, it is very transparent, so you can understand why we are making a prediction that we are making. So that improves trust in the model. The second element is, as I mentioned, the AutoML engine is built right into Cloud EPM, which means it's designed for the needs of finance. And we take care of things like data preparation, feature engineering to define the machine learning model. And we push data into the planning application, into the planning cubes as needed. So all of that work is done for you. So this is not like using an external machine learning model where you have to do all of this work. We take care of all of that work for you. So you can focus on using the machine learning model as opposed to dealing with the technical aspects of machine learning and the technical aspects of data integration and data preparation and so on. So this is our roadmap. We're very excited about this roadmap. And an important application that we are working to deliver, leveraging the AutoML capability that I just talked about, is in the area of cash forecasting. Cash forecasting or cash management is a very, very important use case within finance for machine learning. After all of us know that cash is king. So cash management is very, very important business process. So we are looking to redefine cash management using machine learning approaches, using real-time forecasting, so that our users in finance can gain operational insights and business agility and leverage advanced approaches, such as in collections, you can use things like receivables factoring. You can use strategies like receivables factoring. Or in payments, you can use approaches like dynamic discounting. And you can leverage your banking relationships very, very effectively, right? So this predictive cash forecasting is an application module that we're building, leveraging the AutoML capability that I just talked about. We're very excited about this. In fact, we have another session at CloudWorld where we will preview this predictive cash forecasting capability. So bookmark your schedule for watching that session as well, right? So now let me close this session with a few thoughts. The first one is that we spent a lot of time talking about use cases in the context of financial planning and analysis and financial planning. Those are the most obvious ones that many of our customers think about when we talk about machine learning and artificial intelligence. But we also have several other use cases beyond planning in financial close, in financial consolidation, in account reconciliations, and in reporting. Some of those are listed here. In financial close, for example, machine learning models can help identify exceptions. Not only help identify exceptions, but also recommend exception handling actions using patterns that are detected through machine learning models, right? So this will help in automation. The first step may be not automation. Machine learning model may raise an exception and suggest a corrective action, and a human being may review it and say, yep, this makes sense, I'm going to do it. As you gain more confidence, you may actually automate them. And similarly, in account reconciliations, we can automate transaction matching using machine learning. In narrative reporting, we can intelligently generate narratives using natural language processing technologies or machine learning technologies. For example, if you see a variance, not only can we highlight the variance, we can generate text that tells you here are potential root causes that may be causing this variance. So this is very useful for somebody to understand the variance and take action, right? So those are some use cases beyond planning. So when you look at all of this, you're wondering, okay, where do I get started? Where do I start first? What should I do? So here is some guidance in terms of what you want to do there. The first one is select your target use case with some thought. Oftentimes people think about sales forecasting or revenue forecasting as the most important use case. It could well be, but there may be other use cases that are, better suited within the context of your organization. Think about data availability. Always start with a pilot to gain some experience and trust within your organization. And define success measures. Be realistic in how you define success. Your machine learning algorithm is not going to be 100% accurate, so then don't set the bar too high. So those are some guidances that you can read and incorporate in how you start using machine learning. And finally, here is an example set of use cases for machine learning in the context of finance. Sales forecasting, there are use cases in the tax function for tax planning and tax classification. We talked about cash forecasting. You can even use it for ROI prediction for capital investment projects. So there is a rich set of use cases beyond the revenue forecasting use case that all of us commonly think about. So hopefully this has been a very useful session for you. We are excited about the potential of machine learning and artificial intelligence in the context of finance, in the context of enterprise performance management. Thank you for listening, and we'll wrap it up right there. Thank you for attending.